Okay, we're here with our student Jordan to talk about, ready to go, Jordan?
Yep.
Okay, so first let's talk about graphing one variable inequalities. Okay, let's go ahead and put a graph up here. It looks like there's some highlighting on that graph that's telling us something about, let's say, the variable x. What would you say about x from what you see on the graph here?
X is less than or equal to 3.
Good. So you can see that it's highlighting all the numbers that are less than 3. And what about that or equal part? What's special about this graph that tells you that it's an or equal?
There's a point on the 3.
There's a point on the 3, right? So we can say x is less than or equal to 3. Now let's look at another one here. What is different about this graph other than the direction that's being shaded?
The point on -3 isn't filled in.
Yeah, it's not filled in. It's an open point. So if you were to say about x, what this number line graph is saying about x, how would you state that in math terms?
X is greater than -3.
Right, and you didn't say or equal to because this open dot tells us you cannot have x equal to -3. It can be just a bit above -3, the smallest little increment in front of -3, but it can't be equal to -3, right?
Right.
And we would write it that way. Okay, good. Now, let's just talk about solving inequalities when we don't already have x by itself. So first let's talk about solving with addition and subtraction. So we have this inequality here, x plus 2 is less than 0. And basically, except for some rules that we'll get to right over here, you're going to use the same strategies you would use to solve an equation. This is just an inequality. So you want to get x by itself. What's bugging you there?
The 2.
The 2, and it's being added to x. So what's the opposite of adding?
Subtracting.
Good. So what would you do here to solve?
You'd subtract -2 from both sides.
Yeah, you subtract 2 from both sides. And then what would you have on the left-hand side?
On the left-hand side, you'd have x.
Right, because 2 minus 2 is just 0. So we'll just have x there. And on the right-hand side, you have 0 minus 2, which is?
-2.
Good. And if you were to graph this, it would look like this. An open dot, because this is a less than, not a less than or equal to. And then everything that's less than -2. Make sense?
Yep.
Okay. Now the only tricky part is when you get over here and you're solving with multiplication and division. And I'm just going to tell you a rule here. When multiplying or dividing by a negative, switch the direction of the inequality symbol. You've probably already memorized that, right?
Right.
Okay, so let's do it once and then we'll talk about it a tiny bit more. So we have -3x is less than or equal to -12. What step would you take here to solve for x?
Divide -3x by -3.
Good. And then you have to divide the other side by -3 also, right?
Right.
Because we want to get rid of that -3. It's what's bugging us. It's multiplying by the x, so we do the opposite, we divide. So we could write it like this. -3x divided by -3. And then -12 also divided by -3. But look at what changed here. This was a less than or equal to, and now because we're dividing by a -3, we have to make it a greater than or equal to.
Right.
Okay? So then what remains on the left-hand side?
X.
Just x, because -3 divided by -3 is 1, so that's 1x, so we just write x. And on the right-hand side, it's -12 divided by -3. A negative divided by a negative is a positive, so that's x is greater than or equal to 4, right?
Right.
Okay. So we have this rule here, but I'm going to ask why? Why do we do that? You memorize the rule, but we shouldn't just blindly accept rules. I mean, this is math. We should understand why it's happening. So let's actually solve this same exact problem in a different way to see why we have to switch the inequality symbol, okay? So we'll go ahead and write that exact same problem. And what I'm going to do, instead of dividing by -3, I'm going to add 3x to both sides so I can get x over to this other side with a positive coefficient. So let's just do that. We add 3x to both sides. What are we going to have on the left-hand side then?
We're going to have 6. Sorry, just 0x.
Just 0x, right? Or just 0. Good. And then what will we have on the right-hand side?
I'm not sure.
You'll have the 3x and the -12. So it'll be 3x minus 12. So let's just pause. Does that make sense to you? We added 3x to this side and that got us to 0. And then here we added 3x and we had the -12. We could have written -12 plus 3x, but I just wrote it as 3x minus 12. Make sense?
Mm-hmm.
Okay, now let's solve this like we normally would. We have the 3x and we have the -12. We want to get x by itself. What's bugging us over here?
The -12.
And what would you do to get rid of that?
Add -12.
Okay, so we'll add 12 to both sides to get rid of the -12. What would be on the left-hand side now?
12.
And what would be on the right-hand side?
3x.
And we didn't divide or multiply by a negative, right? So we don't have to switch anything around. So we'll have 12 is less than or equal to 3x. Just pause and see, does that make sense? We got rid of the 12s over here and we added 12 here. Yeah?
Yeah.
Okay, now what's bugging us? What do we need to do?
The 3.
The 3 is bugging us. It's multiplying by the x, so what are we going to do?
Divide by 3.
So we're going to divide both sides by 3. And we're not dividing by a negative, so we're going to keep the inequality symbol the same direction. And then what will we have on the left-hand side?
4.
And what will we have on the right-hand side?
X.
X. So it's now, you can see it's 4 is less than or equal to x. Makes sense to get from here to here?
Right.
Okay.
Yeah.
And then a lot of times when we're solving for a variable, we want to write the variable first. So we're going to write this just in the other direction. And that's x is greater than or equal to 4. Does that make sense to you?
Yep.
And now look at, if we look, that's the exact same answer that we got up here. Okay? So the reason that when we divide or multiply by a negative, that we're switching the inequality symbol is because the direction of the inequality symbol matters. It's not like the equals sign where you can just do whatever you want on both sides. And you can see that when we use this other longer, tedious method, we kind of prove what x equals. So we've kind of created this rule so that we don't make a mistake and get the wrong answer. So that now we know that when we're multiplying or dividing by a negative, we have to switch the direction of that symbol. Does that make sense?
Yeah.
Okay, great. Go ahead and go do all those one variable inequalities, all right?
All right.